Okay, here is my video for lesson 913. This lesson is practicing finding our surface area and our volume again. But we are also going to incorporate here today the volume of different kind of prisms. Yesterday we saw rectangular prisms and we saw those blocks, and we've been kind of counting blocks for volume. We're going to evaluate some different ones here today with some triangular based prisms, some different polygon based prisms, and some cylinders. The big ones today, 28 is kind of a recap of what we were doing yesterday. 29 and 30 is what I really need you to focus on, understand how to do. If those ones still confuse you, make sure those are the ones you're asking questions about. Those are kind of my highlight questions today. And then 31 and 32 are important, but I'm going to go through them a little bit quicker because it's just kind of some good knowledge, but not the essence of the lesson. We are still visualizing here today with these prisms like we always are. Especially if we're trying to sketch them on paper, we really need to visualize it, but there isn't an E-tool today, so I won't be flipping back and forth. Let's get started with 9-28 then. Okay, in this big intro, what it's saying is we've done volume surface area of three-dimensional solids. We've counted the blocks, and we have seen these kind of rectangular prisms like we see here. But what about some different shapes? And that's kind of what we're going to try to get into. Different shapes, and including cylinders, where we get to bring in circles again. First thing in 98 is they want to bring back this old idea from yesterday of drawing this shape as a net. A net is just like if you could flatten this shape by breaking its sides down, or in their way of saying it, like you could break it down so that when it's folded, it looks like the shape here on the right. All right, and the way I'm going to do this is I'm just going to break it down by like top, front, left, right, bottom, back, and break it down into each part. And I'm going to start with the top. And the top here is a 4x3, and so I'm just going to draw that 4x3. And so I go down 4, over 3, and then I just finished my rectangle here. That is my top of my, I could even probably label it T if I wanted. That is the top of my shape. All right, I'm going to do the front now. The front is a 2x3, and so I'm going to go from here down to over 3 and finish that rectangle. That's my front. Okay, the right side here, imagine it kind of like falling down or breaking down. It is a 4x2, and so I'm going to go from to the right of the front, kind of like this is here. I'm going to go over 4, down 2, and complete that rectangle. That's my right side. The left side is the same as the right, but I'm going to put it on the other side. I'm actually going to put it on the left side and go over 4, down 2. That's my left side. Now there's a couple places, actually we got to do the back side still, I almost forgot. Back side is going to be the same as the front, and you could probably put it, I'm going to run out of room on the left, so I'm going to put it next to the right. It doesn't really matter, that's kind of up to you. But that back side again is going to be a 2x3, and so over 3, down 2, and we get the back. And then the last one is the bottom. I'm going to put the bottom under the front. You could probably put that anywhere. I think the best place to probably put it is right under here. And the bottom is the same as the top was, so that's a 4x3, and so I'm going to go down 4, over 3, and that is my bottom. I don't want to use B again I'll use O for bottom. I don't know, it's something to label it, I guess. But that's my net here. That's like if I flattened out this thing as like a cardboard box, so I could step on it and smash it down so that each side is laying flat. That's what it would look like. To check on it, I'll move this, and oops, sorry. And you can see here that this is what they got as well. They do a nice job here labeling the bases. The top and the bottom, I called it. They called those the bases, and they called these sides around here the lateral faces. Okay. If we want to find the surface area of this, we have to find the area of each side of it. The top, the bottom, the left, the right, the front, the back. We got to find the area of each of them and add them together. So that's what we're going to do next. And then we will find the volume right after that. But to start with the surface area, well, this is a 2, like I've said this already before. This is a 2x3 here, which means that 2 times 3 gives this an area of 6, which means the back also has an area of 6. All right, I'm going to start adding those up already. And so if this is part B, I said the front was 6, the back was 6. The top is, it is a 4 by 3, which means an area of 12. And so the top has 12, which means the bottom has an area of 12. And the left side here is a 4 by 2, which means it has an area of 8, which means the right and the left have 8s. And so now I can add all these together and get my surface area. Is this for part B or C? This is for part C. Sorry. It's for part C. All right. And so my surface area, once I add it all together, 6 plus 6 is 12. 12 plus 12 is 24. 24 plus 12 is 36. 36 plus 8 is 44. 44 plus 8 is 52 as a surface area, and I'll say that is units squared. Okay. In a shape like this, we talked about yesterday, there's a couple different ways you could find the volume. We could find the volume of our base, our first stack, and then multiply it by the height. Or the way I'm going to do it here is I'm going to do length times width times height. My length here is 3, my width is 4, and my height is 2. And if I just multiply those together, I will have my volume of this shape. And I'm going to do it this way because we will kind of see this again. Finding that volume of your base by doing 3 times 4 and then multiplying it by that height, we're going to see that again. So that's why I want to use it here. And so volume is 3 times 4 times 2, which gives me 3 times 4 is 12. 12 times 2 is 24. And so that's 24 units cubed for the volume. All right. That is a nice problem. It had us practice drawing a net, which we learned yesterday, and it had us working again to find surface area and volume. I'm going to reiterate one more time before I move on to 29. Really what happened here was by doing 3 times 4, we found that area of the rectangle, this bottom rectangle down here, we found that area by doing 3 times 4, and we just multiplied that by like how many stacks there are, which was the 2 stacks. And we're going to see that with these different, like the special kind of prisms on the next problem. And so if we go to 29 here, we see an example of a triangular prism. All right. And the idea here is, and we'll see it in part C and D, so I guess I can wait a little bit, is we're going to do kind of like what I did last time. We are going to find the area of the base, and we're just going to multiply it by that height. All right, and we did that with a rectangle with the 3 times 4, and then multiplied it by 2 because it was the height, and we're going to see it again here. But let's first figure out what they want us to do. So in A, they want us to draw the prism on our paper to the right. I'm not going to do this for time reasons, so I'm not doing part A. If you want to give it a try, you can. It's just kind of telling you a little trick. You could draw the 2 triangles and then connect them. All right, the next part for part B I am going to do. It wants us to find the surface area of this triangular prism. Okay, and what we're going to do here is we're going to find the area of each part. And so we're going to find the area of the top triangle, the bottom triangle, and then we're going to find the area of all the lateral faces, all of these really pretty much parallelograms here that make up the lateral faces. So in part B here, we have to find the area of the triangle on top. Well, the triangle on top is just a right triangle and doesn't really matter, but we can find the area because we know area of a triangle is 1/2 base times height. And so that becomes 1/2 times 4 times 3. Now 1/2 times 4 times 3 gives me, well, 1/2 times 4 is 2, 2 times 3 is 6. And so the top part here is 6. And so that's part of our surface area. I know that in prisms, the bases, the top and the bottom, are congruent. So if that area is 6, this area down here is also 6 for the bottom triangle. Now all I got to do is find the area of all my lateral faces, which I can see here that my back side here, where the black dot is right here, that is a 4 by 9 rectangle, and so that has a surface area of 4 times 9, which is 36. This rectangle back here with the new black dots on it, that is a 3 by 9 rectangle, so that has a surface area of 3 times 9, which is 27. And this front face here is using this hypotenuse. Now I'm going to do this quickly. We've seen this a lot. This is a 3, 4, 5 triangle. It's a Pythagorean triple, 3, 4, 5. And that means that is a 9 by 5. That is a 9 by 5 rectangle, which means that has a surface area of 45. Okay, so now I have my 3 lateral faces I can add, and I have my 2 triangles I can add. And so I have 6 plus 6 from top and bottom, from the top and bottom triangles. Then I have plus 36, plus 45, and what was my last one? Plus 27. If I add this up, I have my surface area, because I have the area of all my shapes. Well, I'm actually going to bring up my calculator here to do this. I have 6 plus 6 is 12. 12 plus 36 is 48. Plus 45 is 93. Plus 27 gives me a surface area of 120 units squared. Okay. Again, that one was a little trickier than I kind of thought when I first started it, but the idea again is just finding the area of all the pieces, and it's one of those visualization techniques, knowing like I have to find the area of the bottom, the top, the front face, the right face, the back face, and it's a little tougher with these triangular prisms, but the kind of tricky part there too is noticing that that was a 3, 4, 5 triangle to be able to figure out those those lateral faces. All right. The next thing we need to do is we need to find the volume. We need to find the volume of this shape. And it's like I said, actually, it's a good recap of what we were doing in the first problem and what we were doing yesterday. We have to find that base. We have to find the area of the base, and we have to multiply it by the height. Yesterday's problem, how they explained it was, if we can find that area of the first layer, and we know that each layer adding onto it's going to be the exact same, we can just multiply that by the number of layers. We saw that with Paul's tower problem in 912. We found the area, we found the volume of his base, and then we multiplied it by the number of bases, or the number of layers it was made up of. And so what we have here is really we have this base down here, that's a 3 by 4 triangle, 3 by 4 right triangle, and we have 9 of those stacked on top of each other. That's the way I like to think of it. And so if I want to find volume for part C here, what I need to do is find the area of the triangle, which actually we already did, and we said it was 6. It was 1/2 base times height, which was 1/2 times 4 times 3, which gave me 6. And then the area of that layer, that first layer, is 6. Well, there's 9 of those layers, and so I just do 6 times 9, and that gives me a volume of 54 units cubed. And that's one of the big takeaways here. I'm not going to do part D because part D is going to take me a little bit, but that's really the big takeaway I want you to have here, especially in the first video. If we're looking for the volume of one of these prisms, what we want to do, and it doesn't matter if it's part D here, we're going to do the same kind of thing, or if it's a cylinder, it doesn't matter. What we're going to do, we're going to find the area of the base, and we're going to multiply that area by the height. And so like we did here, we found the area of that base was 6, and we multiplied it by the height, that was 9. All right, sometimes it gets a little trickier when the area is harder to find, but that idea remains the same. Okay, and so right now that's where I'm going to leave off, and then we'll pick up with part D, and hopefully, like I said, because the rest of them are a little shorter, I'll be able to finish the rest of them in a second video.